My name is John Lee. I am the lecturer in architecture at Manchester School of Architecture. I've been there nearly 20 years, and I've served in various capacities. I lead one of the modules, two of the modules actually, but overall I lead the technology course in the Masters at the school. So that's my privilege and my main responsibility. It is a great pleasure to be with you today and an honour to speak at this fine institute. When I was thinking about what to speak about, I was thinking, of course, about technology, and I was thinking about the kind of university you are, and that really informed the subject that I wanted to talk to you about today. So, first of all, greetings from Manchester. It doesn't look like this anymore. You should come and visit. It's a lot more clean and tidy. But this was it in its heyday. It's often called the cradle of the Industrial Revolution, the place where the unique qualities of topography and climate, of private enterprise and a workforce, all of those things together provided the conditions for rapid industrialization to take place. All of those things plus technology, of course. And Manchester remains immensely proud of its technological heritage. At the School of Architecture in Manchester, we like to think of ourselves as building on that tradition. As I say, I head up the master's course there, and we have a postgraduate school of about 400 students, so I think a bit smaller than you here in Krakow. I was, for a few years, an associate at Grimshaw, working out of London and Berlin and Manchester in the end, which is how I came to be there. And I also have my own modest practice, doing small projects, continuing to do most interesting work. That's the idea anyway. So this lecture really is about a series of reflections on how we are to understand technology in architecture. We talk a lot about it these days, don't we, in relation to sustainability and in the environment, and of course that's important to do. But I've always been interested in questions of materials and technology, questions I suppose around tectonics. So this is an interesting topic for me. And it turns out that it's an interesting topic for architects as well, or has been, for the architects and the theorists that went before us. So the question I want to ask today is, what is architecture made of? One definition about architecture is about organizing means towards an end, about organizing techniques and technologies, all the things that we need to make buildings, organizing those towards the end goal of a piece of architecture that in various ways will be expressive or integrated and culturally connected and contingent. So the aim of this lecture is really to help us to think about connecting architecture back to technology, and to do that in a way that has theoretical integrity. So at the same time, I want us to gain a bit of an optimism about how technology isn't just something that we work out after we've riffled through Design and ArcDaily to find the image of our building, but actually something that we can integrate into our projects. And I think at the same time, we're also going to talk about some of the assumptions and bring those to the surface, those things which we maybe carry as embedded ideas, but we don't really realize that we have them. And I do this very much with Manchester in mind. Of course, that's where I'm from. And I'll say a little bit at the end about some of the projects that my students have been doing and how they explore the ideas that I'm going to be talking about. But I also talk to you here in Krakow with a tradition of making buildings in a particular way and teaching about them as well. I've organised this talk in three parts, which I'm calling Ironic, Ionic and Iconic, mainly because in English they sound good, but it helps to have a little bit of an organisation about what you're going to say. So let me start with part one, Ironic. I'm going to launch into this subject really by talking about a personal observation I made many years ago when I visited Paris. In 1987, Bernard Tschumi finished his first built project, the Parc de la Villette in Paris. The design was really spectacular at the time. It was a very exciting project, exciting because you're watching somebody who's only ever written about architecture building for the first time, and you want to know what is the connection between the ideas and the buildings. And it was really the first outing for his ideas about deconstructionism in architecture, those theories, which have overlaps with postmodernism, of course. And the winning scheme sought to reject some of the received ideas about what a park should be. It was a design for a park that he was asked to do, or that he won. This was a polluted site, and he sought to recover the site for public use. And if landscape design, to kind of caricature a little bit, has two poles. On the one hand, it can be picturesque, and on the other hand, it can be very formal, like Versailles and the work of Le Notre, for example. And what he did was to break both of those conventions by proposing a series of, to impose a structure on the site which was neither formal and axial, nor was it picturesque. And so he was looking to create, well, basically to reject the idea of a kind of hierarchical composition, as would be implied by neoclassical means. And he proposed that the Cartesian, as it were, would deliberately clash with the sinuous, which would clash with the surface, and the experience of the park would engender all meanings and none. That was what he wanted in this post-modern playground of irony. Well, you might be asking, what's this got to do with architectural technology? Well, it becomes apparent in one of the most interesting aspects, or the main visual aspect of the scheme, which is what Bernard Tschumi called the follies. The follies house the functions of the park, activating the open space around them in lots of different ways through the different functions. In the drawings, they were red. That was a bold graphic statement right from the very start. But the question arises, how should they be constructed? How should they be built? What should the architecture be made of is the question, having come up with the idea. They needed to be red, of course. They needed to stay red, and I'm told that they are still very red. They needed to retain these graphic qualities that won him the competition. And so, in the end, after finding and checking out lots of different materials, they ended up selecting stove enameled steel, which I don't know what that is in Polish, sorry, but it's steel plate which has glass fused to the surface in an oven, like an enamel finish, and that then that keeps the colour in the material. So that was the material that he chose, and that would reliably and forever project this very red graphic quality. So far, all of that's very logical. But what about the structure? Should you choose a steel or a concrete frame? Some of the follies had upper floors, so they needed fire protection. So concrete seemed best. But others were single-story and open-sided and uninhabitable. They were just follies, literally. So they didn't need any of that protection, fire protection. And so pragmatically, what Bernard Tschumi says is that some of the follies will have a steel frame and some of them will have a concrete frame. There is, even in the construction there, almost a deliberate postmodern irony at work. There is, or at play, we might say, because this is something of a game for him, I think, the playful handling of technology. And so for us, I guess what I'm asking all the way through is, does that matter? Does it really matter that there's the technology underneath the surface appearance is different? That you can't tell what something is made of ultimately by looking at it. Because for him, we have to conclude, don't we, that the structural technology is actually not part of the architectural theory. It's not prescribed by the architectural theory, so it's entirely incidental. To put it another way, there's no compelling story to tell about the technology of La Villette. We can only say that the follies are red, and we like how red they are and that they stay red forever. And in a sense, this is the dilemma that we have today in architecture, that we all face using modern methods of construction. The dilemma of what we might call the multi-layer construction, the fact that what we're looking at when we look at a building is not actually usually the structure. It can't be because of cold bridging. So we're looking at something else, and that's hiding various other layers like insulation and vapor barriers and breather membranes, none of which you can see and none of which have, as it were, an architectural voice in the theory. And that's something that for me personally, in this project that we've just finished, my practice has just finished, we wanted a highly insulated envelope, and it was a retrofit project, so this was an existing building that we were converting. We used brick slips. What is the theoretical basis for choosing bricks that are stuck on to a building? So these are questions, these are very present and real questions, both in your thoughts as students, or I think they should be, as much as they are in practice. So that's kind of the ironic, as it were. Let's look at the Ionic. Because I want to ask the question, where did this come from? Where are the origins of the relationship between construction and meaning? Or how far can we go back? And how helpful can that be? And I guess I want to say in this section, it's called Ionic because of the Ionic column, that's all. But in the architecture of antiquity, it's clear that if we could think of this question of means and ends, the means of architecture and the end that is the architecture. In classical architecture, they are entirely coincident. That is, the technology was the meaning, which was the architecture. It's there in the kind of undifferentiated solidity of the Greek temple. We're looking at here one material that is worked and carved and stacked, and it expressed everything that was needed. So the modern distinctions of structure and cladding don't exist, or indeed of decoration, albeit that probably the paint has peeled off this building many centuries ago. Sonis and Lefebvre say this: a classical building, when seen as tenemos, as a world within the world, factured by the rule-based actions of its architects, is a representation of different phenomena of reality. So what they're saying there is that there is no sense of the end in architecture as distinct from any hidden or veiled, suppressed means behind it, as it were. And actually, if we fast forward to today, that purity still has a compelling attraction, for some architects at least. It's the motivation here for the architects Caruso St. John working in Chiswick in London. They are enjoying the solidity and the monumentality and monolithic qualities of using solid stone. And in this house by Perrodin in Lyon, this is a house which has solid stone walls which meet the thermal requirements purely by being very, very, very thick. So one material from the inside to the out, and it has a compelling quality. And even when we come across buildings which are slightly less pure, something like Moneo's Roman Museum of Roman Antiquities in Merida, is trying to convey that same sense of integrity and solidity through the same material everywhere, albeit that inside this building, as in the thermal baths by Peter Zumthor, the baths in Vals, what's hidden behind what you see actually is concrete. But the poetic attraction of still building the way the ancients build it still exists amongst architects today. And if we think about representation as well, the way that buildings are represented, and the way here this Renaissance building is represented, it's represented minus the construction details in the cross-section. So the cross-section, you can see here, the solid floors are cut through with a plain material. So there's a sense that they're trying to draw the ideal as though this building was sculpted out of something solid. Thonis says this again. He says, children of happier times might see in this imperative for order and rationality a quest in the domain of thinking, and also what Thomas Mann called the highly cherished idea of a perfected humanity. So there is embodied in this a kind of reaching for some kind of ideal, and of a human ideal brought to us through the Enlightenment. And this ideal of perfected humanity is revived very strongly in the early parts of the modern movement. It drives the work of people like Le Corbusier, the idea that we can in some way make humanity perfect. We can right the social wrongs through the mode of architecture. And so he, in his work, draws parallels between the engineered utility of the machine and we might say, the kind of clarity of the Greek temple, because together for him they kind of offer another route to the expression of the absolute through this kind of unification of architecture, of technology and of human need as it then is applied to more socially driven contexts. But I think to be fair, it's hard to conclude from the technology when you look under the skin that he really has any interest in how the building is made. This is a site photograph of the Villa Savoie. There's no particular interest in advancing technology in the way that maybe we think about it in these days. Alan Cahoon, the theorist, writes this. He says the architects of the 20s were less concerned with creating functional architecture than they were with creating the symbolism for a new social and cultural order. So these things are symbolic, they're plastic, they're solid, they're impenetrable. They speak of a sort of collective humanity as well as a perfected humanity in some ways. And they do that for the same reason, as I say, in the same way that the architects of antiquity did so. And to the extent that high modernism is kind of has a slight disinterest in technology, it doesn't matter if our buildings end up very heavy and very kind of earthbound. The monolithic qualities are the things that are valued here. And we'll come back to that as a question a bit later on, where modernism goes after that. Well, let's talk about part 3. And this is where the main chunk of what I'm going to say is going to appear, the iconic. What I'm calling the iconic era, as it were, features buildings celebrating technological expression through architecture. It's where I want to spend most of the time now, the remaining time, because it's in some measure, at least, I think, the key to recovering this lost meaning in architecture, or at least the danger that it completely is erased from future architecture. So where did that era of celebrating technology in architecture come from? Well, of course, famously it came through the Great Exhibition in 1851. And it did this not just because they needed an iconic structure as a centerpiece of the Great Exhibition. Because at this point in time, industrial society in Britain had matured to a point where science had successfully taken the country from an agrarian society, that is, agricultural society, into the age of steam and iron. That happened in Manchester especially, but then that was then exported all around the world. The time of the inventor had arrived, the engineer, the first new profession of the Industrial Revolution. As a number of authors have observed, he was to become elevated, as it were, to some kind of prophet of this new age, this new era in time. He could conjure up these otherworldly and infernal machines from these beautifully precise ink drawings. They were the wise men of their day, given and imbued with an Enlightenment optimism. And through that, they extended their reach. The engineer was initially concerned with the engine, but then was concerned with what the engine was on, and then how the engine was then housed. So the engineer extended their influence until they were designing beams and columns and roofs and whole buildings. Everything they touched turned to iron, in a sense. But during this period, slightly before the 19th century, architects, meanwhile, there's the engineers here, the architects, meanwhile, were fixated on the ideal and the transcendent in architecture. Frampton talks about the French architecture of this period, pointing out how Boulez and his obsession with mass and solid, while his compatriot Logier played with the effects of transparency and framework. That's how he reads those two poles, as it were. But architects were detached, in a sense, from reality. They were like theoretical scientists working in a rarefied field of pure science, and they were drawing down kind of celestial ideas down to earth and trying to capture them and embody them in architecture. Frampton says that they were not interested in the appearance of objects, but in the capacity of objects to reveal the intrinsic structure lying beyond all experience. By the middle of the 19th century, engineers were free to invent. They didn't have any of their colleagues' cumbersome deference to the sacred, and they'd busily generate all kinds of possibilities, all kinds of inventions, that more inventions perhaps than the world had use for, like a self-raising hat. In case you greet someone on the street, you don't have to use your hands, or some kind of duck. I don't know what that is in the middle. If the earlier age was about finding an answer to a problem, for this particular period in history, the problem was finding the question. You could create all these things. What are you going to do with them, is really the question. But it also raises big philosophical questions, and Hannah Arendt puts it like this. She says, the Cartesian method of securing certainty against doubt corresponded most precisely to the most obvious conclusion to be drawn from the new physical science. Though one cannot know the truth now, man can at least know what he makes himself. This indeed, she goes on, became the most general and most generally accepted attitude of the modern age. And it is this conviction, rather than the doubt underlying it, that propelled one generation after another for more than 300 years into an ever-quickening pace of discovery and development. So what she's saying there is she's saying that the relentless optimism of the Enlightenment project turned mankind, as it were, in on itself, so that in this godless age, what he makes himself was the only certainty. There was a detachment from, as it were, some of the I guess, the moral questions, perhaps, or moral foundations. Or at least that was the danger. And it was into this world that the Crystal Palace was born, the centerpiece of the Great Exhibition, with its contents, which offered vast, unexplored possibilities for technology and for decoration and elaboration. The Great Exhibition, Frampton again says, it revealed to the public the mind-expanding possibility of an unknown future laden with all kinds of potential. He says that with the Crystal Palace, the question of how began at a public level to take precedence over the issue of what. So he's making the point again about means and ends and how the one is potentially detached from the other. Now, as architects looked at the Great Exhibition, they were increasingly seeing that they had to catch up with the way things were changing. There seemed at this point that little couldn't be solved by technology. And what do we make of this as architecture? That was what they reflected on. A building that's 560 meters long and 124 meters wide. Well, Ruskin, he said memorably that it's nothing but a large greenhouse. And in saying that, what he's doing is exposing a problem, a profound problem facing architects, because architecturally the building was unambitious. It was boring or banal even. It didn't have any of the subtleties and the hierarchies and the language, the elaborate language of architecture that went before. I mean, Paxton was a gardener, for goodness sake. He was no architect. And so it was impressive, but typologically it was banal. It fitted one classification only, a greenhouse. And so for the first time in architectural history, we might say that technology had advanced beyond architecture, and it was the architects who were preoccupied with something transcendent instead of something real that were left to catch up. And so what did they do? What did they do when, because their authority is being questioned, really? What do they do? Well, the first possibility, the first temptation was to retreat back into craft, to say that architecture is really about craft. So in the face of machine repetition and industrial production techniques, Ruskin again and his school advanced the idea of the traditional industrious craftsman. This is bringing morality back into architecture. And they're making very clear judgments about the society that's producing the kind of building like the Crystal Palace. C.R. Ashby, who was one of the proponents of the arts and crafts movement, advanced a kind of socialism that was not revolutionary but constructive, he would have said, negotiating with the machine. He describes himself and his arts and crafts colleagues as seeking to put into place of the old order that is passing away something finer, nobler, saner. They want to determine the limitations of the factory system, to regulate machinery, to get back to the realities of labour and human life. So yes, wrapped in this technological nostalgia, we might say, was a forceful moral purpose. The personal work of one man at a workbench, or one woman at a workbench, had a nobility and a moral value which could never be matched by industrialized component techniques. These were, after all, they reasoned, these were the techniques that built the greatest buildings of history, the temples, the cathedrals, the palaces, and the halls of the past. So out of this came the arts and crafts movement and a return to, as it were, proximity to the methods of production, values that needed to be revived if architecture wasn't to be amoral and purposeless without any meaning. So there was one response, the retreat back into craft. But second, there was I guess the more positive response of assimilation. The notion that these technologies could and should be absorbed into a new canon of architecture in some way. And at the same time, what was happening, there were new typologies of architecture appearing that asked questions that possibly the new technologies could answer. And that was in part the reason for the great expansion of styles that we get in the Victorian period in England, the eclecticism, lots of different styles, the Gothic and the classical and strange mixes of the two. German theorists and practitioners address themselves, as we might expect, to a very ordered and rational and reasoned classification. They believed, well, I'm thinking here of Semper and Heinrich Hübsch, they could constrain architectural ideal in a tectonic theory, the first time that really this was expressed. And their ideas amounted to, as it were, an attempt to get to, as it were, the essence of construction and to create some kind of classification that everybody could use and refer to as some kind of benchmark or measure. One author describes how Hübsch brought an empirical rigour to the work of form finding of the architect. He says this: Hubsch attempted to identify the objective principles for the development of a new style based on need of comfort and solidity. A style, he argued, is best defined by its primary elements of roof and supports, and the two basic types are trabeated, that is beamed, and arcuated or vaulted systems. He goes on, other factors affecting the creation of a style are local and traditional building materials, contemporary technostatic influences, that is the technology arising from the materials, the need for protection and durability as conditioned by climates, and finally, cultural aspirations. So there's an idea there that somehow the construction can carry all of these possibilities within it, within the material properties, and that could be codified, made into a set of rules. In contrast, in Semper's seminal theory of construction, 4 elements of architecture are always present for him: the hearth, the earthwork, the framework or roof, and the enclosure. For Frampton, Semper's contribution was to humanize this dry systematization of the discipline. So, in contrast to Hubsch, Semper describes how things are made. Frampton says he adds a specific anthropological dimension to the idea of tectonic form. So in a sense, Semper's theory describes life lived, not just buildings built. There is a person in the picture, as it were. So Semper's conviction sprang from seeing a model of a primitive Caribbean hut at the Great Exhibition, leading him to reject an idealized the idealized architectural notion that Logier had put forward, the idea of a primitive hut. It's more complicated, is what Semper concluded. And he published his theoretical treatise only a year or two after visiting the Great Exhibition. Such was the impact on him. So by placing the needs of man at the center of tectonic theory, Semper was attempting to reground architecture in the practicalities of modern life without sacrificing its claim to authority in regard to meaning and purpose, because this was what was still at stake. Could architecture be meaningful in an age of the engineer? And I guess Viollet-le-Duc is another example of a practitioner who was preeminent in embracing these new iron technologies by recognizing that their unique properties could herald a new age of honesty in construction, something that was entirely compatible and fitted with the ambitions, say, of Gothic architecture and its constructional authenticity and purity. That these forms, the slender forms of iron, could express the loads passing through the building every bit as much as a Gothic arch could. His material ideas, the ideas of how you could use this new material of steel or indeed iron, were taken up by Horta. And the other Art Nouveau architects who saw that when you could bend and fold and twist this material, this new material, into expressive forms never seen before, forms that would be expressing organic properties, the sort of semi-liquid nature retained in the frozen, solidified metal. Remember, we're still thinking about how these technologies are assimilated into an architecture. And these, as I say, these remain important questions for us. If the modern idea of truth to materials came from Viollet-le-Duc, the modern idea of reflecting the age can be traced back to Otto Wagner, I think. Writing in 1896, he lamented the disconnect of architecture and the public. For him, he was concerned about the question of intelligibility, whether if you look at a building, you could understand and read it, as it were, and that the public couldn't make that connection well. So he wanted to address that. He said that the main reason that the importance of the architect has not been fully appreciated lies in the store of forms employed by him up to now. That is, in the language he has directed to the public, which in most cases is completely unintelligible. So he's working at the end of the 19th century in Vienna, and there are all these new typologies that are appearing, and the question is, how should they be expressed? How should you express building types that had never existed before? And as he was working and as he was teaching, his convictions about the new era of architecture solidified. He came to believe that architecture should represent the age in which it was conceived. And that, obviously, is the foundation of one of the great rules of modernism, that it should be what it should look like what it is. Architecture's basis for Wagner was to become not symbolic formalism, but construction and technology. The architect, he says, was to train himself first by learning the language of engineers, and second, by giving that language and values artistic refinement. So-called architectural realism was the outcome, and it's for us in our teaching, it's a period of architecture that's really fascinating, lying between two eras, where you have architects who are stylistically connected in some way to the era that precedes, but they are looking ahead to the modern era and modern architectural problem solving. Wagner saw that realism was a primary attribute of modern life. And in that way, it presented a means to oppose untruth and inauthenticity, the false pathos and empty phrase-making of eclecticism. So it remains interesting for me, this idea of assimilation. If you look at the Postal Savings Bank of 1906, it uses steel and iron technology to create this luminous tent-like hall at the heart of the building. It's seemingly kind of inflated by the air vents at the end of the space that give it this volumetric lightness. And externally, it's equally honest. The rusticated granite cladding is expressly bolted onto the backing by aluminium studs. None of the construction is hidden away. And the canopy, the supports on the left-hand side there, are supported by cast aluminium columns that are ribbed, as it were, to describe the forces that are moving through the column along their length. And in a further evidence of the kind of assimilation, I suppose, here he is embracing the civic possibilities of engineered infrastructure. So he's giving the engineering an architectural intent. So it's not just, it's not dumb, it has a purpose and a meaning, and it speaks to the populace of fin de siècle Vienna. And it wasn't just those buildings, but also the buildings for the Stadtbahn that he also designed, that were new building types that needed a new architecture. And he, again, interesting, sitting in this camp between the old and the new, he finds an architecture which doesn't sit in either very convincingly. Look, where are we up to? The Great Exhibition offered means without ends, and architecture had been long preoccupied with ends without means. And it was in this period of assimilation that in Vienna, in Belgium, in London, that there was the beginnings of this reconciliation going on between engineering and architecture, means and ends being brought together again where they had been apart for a number of years. I've already argued that high modernism belongs to this kind of Ionic era of architecture, the idea of a kind of idealized form where the technology is shielded and hidden from view. But the iconic role, as it were, of technology in architecture took a while to be revived. It could be said to have taken until the 1950s and Buckminster Fuller. And then in the 1960s, in the work of Archigram, for this enthusiasm for technology and architecture to be revived, for this return to the potential of technologies unleashed in the 19th century. The architects of that movement are household names of Foster and Rogers and Hopkins and Grimshaw. They saw themselves as the descendants of Brunel and Paxton and Stevenson. And certainly in my time at the office, those conversations were explicit. They were calling on and drawing on the heritage of the great engineers of the 19th century as they looked at their own architecture. And here's Grimshaw take his own take on the great engine shed, the great railway sheds of the 19th century, the Eurostar terminal in Waterloo in London. And they worked with, all of these architects worked with the great engineers of the time. They were reliant on them, but they also partnered with them so that the solutions that they were producing had both architectural and engineering integrity. And they created some of the most striking buildings of the late 20th century. These works of the high-tech school in architecture emerged at a time in the UK at least, where there was a great optimism about technology and how it could solve social problems. Again, it was called the white heat period of technology. And again, there was this optimism that everything could be solved through kind of the men in white coats, the scientists working in laboratories. And encapsulating this relentless, uncritical, I guess, optimism, high-tech architects also, in some sense, domesticated the wild threat, I suppose, of technology, because technology and technological change can also be threatening. So some of their work, as they put the work of Archigram into practice, ended up being making it more approachable, more acceptable, even though it looked very different. They made it move and walk. They imported the language of pop art into architecture. And there's no question that the Centre Pompidou in Paris is the most celebrated building of this era and of this style. If we come back to this question of means and ends again, then we might say that it shares with classicism the exact coincidence of means and ends, that when you look at the building, you're looking at what it is. There's nothing hidden away. But whereas the means in classicism is entirely suppressed, you can't see those forces moving through the fat columns of the temple, the means in high-tech architecture is entirely expressed. So you see everything. You see not just the structure, but you see all of the breathing mechanisms of the building, all of the veins and the muscles are all apparent. So from the Crystal Palace through Buckminster Fuller, we arrive at the Culture Palace, a kind of an idea of a democratized architecture of supreme transparency, which technology allows. This is an anti-institution, an institution with no facade. And those heroic qualities, the technologies of steel and plate glass, of escalators and ventilators, they all make it possible. Well, now this literal and metaphorical transparency was inspected very closely by critics and theoreticians of the time. Alan Cahoon, writing in 1977 in the Architecture Review, found a flaw in this vision of architecture. He saw a mistake, and it concerned a fire separation wall in the Pompidou Centre. The wall was built along the line of one of the huge trusses. It was necessary because the floors were too big. This great open span space was just too big for fire regulations. And so there had to be a firewall inserted on one of the trusses. And because everything is on show and nothing is hidden away, everything is architecture. And so Alan Cahoon quite rightly asked the question, what is the architectural meaning of this fire separation wall in a building of supreme transparency and openness and flexibility? So there was a functional reason, but no architectural reason. Skepticism about this optimism was coming. And Solon Morales also has spoken about this skepticism. He talks in his essay, High-Tech Functionalism or Rhetoric. He says this, that the application of technology has made the complex seem disarmingly simple. He writes this: ideologically, this whole conceptual apparatus results in a clearly defined rhetorical message. In a world full of conflicts such as ours in these final years of the 20th century when he was writing, such architectures present themselves in the first place as something obvious, evident, logical, rational, and economical. And he says, what greater poignancy than that of the victory of wisely administered technique? What he's doing is he's questioning the deception, like a magician, something that's hidden away. There's a kind of game and a conceit that's taking place. And on more than one occasion, working in that kind of office, you had to ask the question, are we overcomplicating a simple question for the sake of creating something of technological brilliance or exuberance? And that's exactly what Solomon has put his finger on. These things that are dealt with great flourish, leaving, as it were, many of the traditional preoccupations of architecture, the important things that we do as architects, left unanswered. Back to my question at the very start, how we lost meaning in construction, and how can we recover it, I guess, is a good question to ask as well. For me, the solution, I'm going to say right out, starts in the idea of expression, of expressive technology, which is in it also derived from qualities of human subjectivity, of culture, of the way we do things together, of endeavour and of art. I guess to give an example of that, I would go to Carlo Scarpa. So he, in a kind of flicker, as it were, of the arts and crafts movement, he ploughed alone this means and methodology of making architecture, working with the craftsmen, quiet, patient working, and in doing so, elevating the detail of the building so that it has a compelling immediacy, something that brings the mind of the architect to bear on a technical problem in the very workshop where the components are being made. And in this exuberant elaboration, Scarpa's details unashamedly embrace well, let's say it, it's ornamented architecture. And I and we at the school are interested in the question of ornaments within the chair in which I teach. The idea of embellished utility, like that column that Otto Wagner designed. The idea that we all in some way like to express ourselves, our culture, our skill, and the skill of people making things in the elements and components of our architecture. So this embellished utility which Scarpa develops to a fine art, literally to an art, connects him to the ancients and their architecture. It's as I say, it's an expression of technology that's still spoken in hushed tones, yet I believe is every architect's guilty secret. The idea that they actually can't always find a functional justification for every single thing that they do in a building. And actually, that's okay. It's not really a big problem. It's only a problem for us, but it was never a problem in the past. I mean, just to close, and then I'll show you a little bit of work. Mark Pimlott writes this about ornaments in architecture. He says, a consideration of any monuments of antiquity will show that the elements of construction are representations. They are ideas about what buildings do and say, he says. Representation and ideas are part of architecture's nature, and fantasy and the impulse to ornamentation are joined to its fundamental ideas. It's inescapable, and it's even desirable to think about architecture and what we do in that way. Well, to finish then, what is the way forward? Well, I think it comes in part through teaching. That's what I believe, that we are effecting change in architecture, and we're exploring new ideas. And we explore particularly this desire in all people and in all peoples to express something of themselves, something of their society and their culture in the things that they make. We like, in our work, to tell stories through construction. We like our projects to begin with a narrative process, a process of telling the next chapter of the story of the city or the place, or even at the level of the building. What is the next part of the story? And so we develop narrative ideas, in this case, the idea of a parallel city, a new circulation system through the town of Accrington. We also enjoy always the exploration of tectonic qualities of the architecture, making things or proposing to make things which people can and will engage with because of the quality and the connection to place and the way that there's sentences within the story of the place that we're working. So people make things like this. That is what we're interested in. That we're also looking at construction in relation to space, understanding that construction affects space. It's not a neutral, it's not something that's just hidden away, but that construction can shape and form and create vessels within architecture for the functions that we're looking at. And it can be, at times, expressive and exuberant with poetic detailing, ways of getting rainwater off the building or of creating surfaces which weather beautifully over time. And those impulses, the things that we teach, the enthusiasms about tectonics, about construction, about architecture, about place, about people, about culture, they're all finding their way into architecture, new architecture in the UK. And our students go to work for practices like these, where they go further and explore deeper the new tectonics that we think is the future of architecture. For architects then, that desire, I believe, will always reside in us, the desire about how to make meaning as we make components and we make assemblies and we make envelopes, as we make architecture. Thank you. Now, I know it's traditional at this point to ask if anyone has any questions, and the only people who have questions are the professors. But my colleague always says, wait 90 seconds. Does anyone have any questions? Then you wait 90 seconds, because 90 seconds is exactly the amount of time you need to make people feel awkward. Any questions?
Your colleague has forgotten that it makes also awkward the one who's measuring the time.
That's me. Exactly.
You are not excluded from this.
Well, as I say, these are personal reflections. They're not final. They're thoughts about architecture. I hope they're stimulating to you as you think about your buildings. You're very early on in your projects in this semester, but as you go on, you'll be thinking about, and your professors will be asking you to think about how things are made, and I hope that you'll remember this lecture. Thank you.